So today we are talking about backups, redundancy, and cloud computing. So basically what we're talking about is how we recover from something going wrong, or making sure that we can withstand adverse conditions within the organization. And from a technical point of view, what can we put into place to stop everything from falling over and dying when we get too much traffic. So, as we talked about last week, an organization needs to actually plan for when things go wrong, and they need to be able to recover from events and actually prevent the problems in the first place. So continue to be able to do the things that they need to do for their organization. So really basic terminology here. You all know what backups are, because you use computers. So we back up so that we can back up to restore to how we were in a previous state. So it allows us to actually recover an earlier version of our data, and so before something went wrong, before it was modified or deleted or whatever, we can get back that copy. And everyone should have some form of backups if you're using a computer. I did this last year and I got a surprising result, but hands up if you have never lost something that you wish that you hadn't lost. If you've never ever had a lost data due to accidentally deleting it, or not saving something, an assignment you're working on or something like that. Show of hands. One person in a class, possibly two. You're not committing. Taz. Maybe.
Important, but I thought, I'd quite like to have that still.
Yeah.
So much.
Some of you have lost a lot, and somehow, is it because you back things up?
I've always been really get the drive become corrupted or something like that, so I've always just kept a copy.
Right, it's not because you've just never needed a backup, it's just that you do backups well, is the reason you haven't lost stuff.
That's all I've ever known to back up.
I mean, I do backups, but not everything. And once I lost an entire, back when I actually used Windows, I had my C drive, my main partition died, and then there wasn't anything super important on it, except all of my emails for the previous 10 years or something. And it's not great. I didn't have that backed up, but then again, it wasn't important enough to take the controller off the, and actually try and fix the hard drive or whatever. But yeah, so we've all lost things. You've lost a lot, have you? Yeah.
Nearly just whole computer's worth, but
yeah.
I've resorted to buying a RAID backup now, so I never lose anything.
Yeah. You use RAID, not really a backup.
RAID 1.
But yeah.
Backup. I've got 2 drives.
Yeah. Redundancy.
Yeah.
But if you accidentally delete everything, it will get deleted off both. So it's not a backup, but it provides redundancy in case a hard drive dies by itself.
Yeah. Oh,
yeah.
But the only thing I'm using it for is to back up everything on my computer.
Yeah. Cool. Anyone else want to have any anecdotal stories that they want to share?
A few days last week, I started my research.
Last week.
All my research stuff from my
Yeah.
final year project.
Yeah.
My pen drive malfunctioned. Don't lie. And I was
How much work did you lose?
Well, I thought I'd actually backed up before.
Yeah.
I give my pen drive to him, and actually last time I backed up, I went, probably a weekend, and I looked at my backup, and it wasn't up from, the last time it was backed up was last year. I thought I backed up, but
That's a big difference, last year or last weekend to last
He
backup.
got my data back luckily, but
Yeah, well that's lucky. So I think we all have first-hand experiences of accidentally losing things, and whether or not we happen to have a backup in place. So we can use backups to mitigate various risks. So we might accidentally lose some data, due to either deletion or corruption. We might have hardware damage, so a hard drive might die, which was in my case the thing that happened to me. Show of hands if you've had a hard drive die on you. Yeah. Okay.
Have you ever had one set itself to read only and you can't get it back?
Right.
Ever seen that?
I haven't seen that.
I've had it happen 3 times.
I think on average hard drives die every 5 years. I think it's the average lifespan of a hard drive, I think, from memory.
Seagate are all
Yes.
Graphs.
So you kind of have to assume hard drives are going to die at some point. And if you got a large organization, they'll go through them. Yeah.
I've got a network drive. It's a Shiba network drive.
Mm.
It's just where we store any loads and loads of crap on it.
Yeah.
And we've had that for 8 years. No. 10
Like a
years.
NAS.
I don't think it's a NAS. I know I might be wrong. It's just a noisy box made by. It's like a tank. Anything that Toshiba makes is essentially a tank.
Yeah, but it provides it's
It's accessible through a network. But
yeah. So it's network attached storage. So yeah.
That's nice,
Yeah.
Okay,
Yeah.
But yeah, that's still running.
Yeah,
Noisy as
well, that's
hell, but
good.
Still running. It's not broke yet.
Yeah. So that's actually hard drive dying, and then it could be like a malicious attack. So either, obviously like malware, or actually, denial of service attack, or someone maliciously doing something on a computer. Right. So all these things can result in us losing information. We want to be able to get it back somehow. So in order to do that successfully, we need a backup plan. So as part of your disaster recovery planning, and your continuity planning, you should basically have a plan in place that's documented, and it describes how we're actually going to do backups and recover from backups. So we'll start by identifying what our requirements are, so storage requirements, so we'll have work units, data centers, systems, so all the people within the organization, what is it that we actually need to back up and be able to get back. We need to have, these are terminology that we discussed last week, recovery point objectives and recovery time objectives. So that's what we are aiming for in terms of what will allow to go wrong, and how much time we'll give ourselves, and how much data will be an acceptable amount to lose. So for example, do we back up every day, or is it okay if we lose a day's worth of work and we'll just back up weekly? Those are the decisions that need to get made. And we need to specify who, how often backups are happening. It needs to be actually decided and made formal. So you're in charge of backups for this office, and you're doing it this often and onto this medium or whatever. And how long do we keep the backups for? Because storage is cheap-ish, but depending on how much we've got to store, we're not going to store everything forever. If we're doing a weekly backup, how many weeks of those do we keep on file, and how often do we just delete them or write over them? Where are we storing our backups? What are we backing up? And how we actually go about recovering from a backup. So, we need to think about what's the value of the data versus the cost of having all this in place. If we're going to have to buy a whole bunch of hard drives and somewhere to store the information, or paying someone else to store it for us, what is the value of what we're storing? So for example, if we've got a bunch of Windows or Linux systems, what are we backing up? We're backing up home directories, which has the work that someone's done, or the entire operating system, including just all of everything, all the programs and everything on that computer. And is it more important that we can just get that entire computer back to how it was, or is it just important that the actual information that we want to keep hold of, that's backed up, and we could always just reinstall Windows or Linux onto a different computer and then pull down the home directory? So yeah, how fast does it have to happen? Tape's super cheap. It's still a cheap medium. You can buy tape storage that have actual, drives that have, like a cassette tape kind of thing inside them, and you can store files to that. And that traditionally has been the cheapest way of backing up information. And it's still, whether that's still the best option, it's still a cheap option that you can use. But it takes a really long time to recover anything from it, because you can't just take a file off it. You kind of have to seek all the way through the tape to get to the point where the data is that you want. So it's cheap, but it takes a long time. So, what can we store our backups onto? We've got tape, optical storage, which I don't think makes much sense anymore as a backup medium, but for a while it was super cheap. You can get Blu-ray discs that you can write to, but I'm not sure that's really a cost-effective option at the moment. Does anyone? Yeah.
It's like 20 quid for 5 still, I think.
Yeah. So it's not the cheapest thing at the moment. For quite a few years it was. When DVDs were first, writable DVDs were out, that was cheaper than storing onto a hard drive. But hard disks and solid-state drives are other options. So a hard disk is obviously cheaper per gigabyte or per terabyte than a solid state drive is, but it's a bit slower in certain ways. Has different set of limitations. And then there's types of backup. So we can either back something up to medium we've directly got plugged into a computer, so which pretty boring and normal though. So you just like plug something into the computer, copy it onto it. Network based, so we've got internet and cloud based backup. NAS, so network attached storage. So we have like a computer that's basically dedicated to providing a storage space on our network. Usually it's just a little computer full of hard drives. We plug that into the network and then we can back up to that. Or using networked systems and file systems and things, we might have a server that also provides a place that we can back stuff up onto. So backup levels, there are lots of different ways you can manage backups. And not incredibly exciting, but something worth knowing about, right? So you can do what's known as an epoch backup, so like a full backup, and that's just when you take everything. So say, for example, I want to back up my PC. An epoch backup would be taking a copy of everything on that entire computer and putting it on something and storing it. What happens the next week when I want to store something and I want to make sure I've got a backup of everything? What do you think would be a a logical thing to do the following week when I want to do a backup?
Just back up the changes.
Check the new files.
So yeah, only back up the changes, and the new files is a good point. So that's what differential backups are, because we don't want to go through copy all of that all over again if we don't need to. So we just copy the things that have changed. So a differential backup is where you have usually into a new directory or whatever, you would just have the files that have changed since the last epoch backup. So since the last full backup, we've got a separate place where we just put the new things that have changed. One way you can do that is either just copy the entire files that have changed, or you can use delta encoding, which is where you just store the differences in those files. So you guys have used the diff command now. You've done that in the labs, and you can see from when you use diff, it will show you which lines within a file have changed. So that's an example of delta encoding, where you just save the changes rather than complete copies of files that have changed. You can also use incremental backups, which is actually just the changes since the last backup, even if the last backup was a differential backup, right? So the following week, so week 3, if we're only doing weekly backups, so week 1 we did a full backup. I got my entire copy of my computer, made a copy of it. Week 2, I just stored the files that have changed in that last week. Now if I was going to do another differential backup, that would be all the files that had changed since week 1 again in week 3. But an incremental backup is where we just the files that have changed since the last backup, even if it wasn't a full backup. Does that make sense? All right, awesome. So and then things get even more complicated. So you can do multi-level backup plans and things. So level 0 is when you do a full backup. So you might say every month I'm doing a level 0 backup, so I'm going to back up everything since last month. But then you might say every week I'm going to do a differential backup, so that I've got a copy of everything since the last full backup. And then you might say every day I'm going to do an incremental backup, so that's all the things that have changed since the last daily backup, right? So does that make sense? So, well, it does, but am I explaining it clearly? So it's just you choose how much of the stuff you're backing up each time, and then when you want to recover, you need to look at where things are stored and pull things back in the right order. So just to repeat that a little bit, level 0 is when you just copy everything. Level 1 are changes since level 0, and then level 2 are changes since level 1. So in that case, when you want to restore, you need to check which file was the most recent copy. And if you want to restore an entire system, you need to start by restoring the most recent level 0, then the most recent level 1, and then the most recent level 2. And then that'll get you your entire system back. So you might have system images in an organization. So, that wouldn't make much sense to do that for every computer in an organization if every computer was almost the same, right? So say here in our offices, where I guess I'm the odd one out because I'm using Linux, but most people are using basically like the same Windows image on all their computers, then it wouldn't make much sense to do full backups of every single Windows computer if they are all basically exactly the same. So in that case, you might actually just back up the home directory, and or you might even not even store the home directory on their own computers. You might have the home directory stored on a network drive that you just access, and then you can just walk up to any computer, kind of like we have in the labs, where if you use the university network, you can log into any computer and you've got the same file sitting on your desktop, because that home directory isn't actually stored on that computer, it's stored on a remote network drive. So the base image itself is the same. We don't need to back that up because we've already got that image saved somewhere that we can easily pull back, and then we just have to make sure that the user home directory is backed up somewhere. So another approach is to actually have continuous data protection. So we can actually set up real-time backup. So we could set it up so that we're actually syncing every single change as it happens to a remote system. And we can also save history with files as well. So some things like, I know SpiderOak does it, which is like a network, like a cloud-based storage platform, like Google Drive kind of thing, where it'll automatically, if you save it into the right directory, every time you click save in a document, it will sync that directly up to their remote version of it, and it saves the history of the document as well. So if you want to go back to a specific version of it, you can just ask for it. And version control is a related idea. So if you guys have done much programming before, you might be familiar with things like Git and Subversion and stuff, which is a way of managing source code within a project so that you can save the history of the source code. And it's also very helpful when you've got multiple people working on the same source code. But in terms of backup, it's quite a nice thing to have, because you can see the different versions of that source code and pull down different versions, and it preserves the entire history. So there's lots of different ways we can go about doing it. If we were using tapes, for example, we might want to reuse certain tapes. So if we got that multi-level backup system, your full backup tape, you might only keep one of those. You might not need to keep more, further back than a month, or maybe you keep a certain number of them, and then you just reuse those tapes. And you might actually send copies over to a remote disaster recovery site. So if you've got your secondary site that your organization can relocate to, you might have a copy of your backups sent there because it's safe. And all of this information is feeling very old-fashioned. But depending on your organization, you might still resort to doing that. Yes?
Remote disaster backup, would that be similar to like a cold site?
Yes. Yeah, exactly. So, like I said last week, it could either be a cold site, which is where it's somewhere like you could go if you need to, but you need to do a bit of work to get things working again, or you can have sites that are more prepared for that than that, so that you can basically just go in and it's all ready to go. But you'd have to be pretty financially capable to have like a secondary site where it's all ready to go, like maybe Wall Street or something like that would go to that level of preparedness to just be able to relocate and just keep working. But for most organizations, that's like that cost would be quite high to be able to actually have that. So security of backups, right? If you've got a copy of all of your information, we're thinking about security all the time, right? We can put all these access controls in place and all these features and things to protect our files on our computers. But as soon as we've got a backup of it, that's another copy of the data that we need to protect, right? That could be your weakest link. If you are just copying everything off the computer onto another computer and you don't protect that properly, then that's all of your important information there as well. So you need to make sure that that's just as secure. So you look at physical security. Is it actually somewhere that's secure? Is it fireproof? Like if you're talking about disasters and things, if our backup is just kept on a hard drive, in the same building as the stuff that we're trying to protect. That's only going to protect us against certain things. So it's about risk management. So if one of your risks is fire or earthquake, then depending on if it's worth mitigating that risk, you might want to make sure that you've actually got a copy of your information off-site. And you can use like write protected media. So for example, you can make sure that no one can write to that if they don't need to. And sometimes they might decide for themselves that they don't want to be written to, but things like tapes usually have like a switch that you can switch to, so that the hardware will stop it from writing to it unless it's switched onto a like write mode. But also the same with if we're backing up to a network drive, we might allow certain computers to access the backups, but only other computers to write to the backups and things like that. So we control who can write to the backups and read from them. And encryption is a great idea, especially if you're storing it off-site, because if you don't have control over the physical security, then you want to make sure you've got some pretty good data security going on. So if you encrypt, you actually securely encrypt your backups, then that is a very good idea. And if you're using servers for network backups and things, then make sure your file permissions are actually set in a way that makes sense, so that you're still protecting things. There are some laws about data retention. So here in the UK, we've got the Data Protection Act, 1998, which says that personal data should not be kept longer than necessary, and however you decide to interpret that. Laws should measures should protect personal data against unauthorized access or loss. So you actually need to make sure that you are protecting it. You're not allowed to not have security in place, because that's neglect, basically. That's principle 7. And personal data should not be transferred outside the European Economic Area, unless the destination's laws provide similar protections. And that's an interesting one that we come back to when we start talking about the cloud. So basically, there are laws within Europe that specifies that you can't just start storing personal information about people on other servers. So you can't just go, oh yeah, I'm going to buy storage somewhere in America and store all my files there. Well, actually, you're not allowed to, unless there are specific things are met. Yes, Chris?
When it comes to the question of personal data, I can understand it if you're a business holding onto personal data of customers, but
Yeah.
what about your own personal data?
Like, you can choose whatever you want to do with your own data. I mean, you can do, that's fine. It's only if you're responsible for other people's information.
But I mean, that's what I mean. But what I'm thinking is, say you, for example, there's a hard drive and it's got all your data on it, and it's not protected under the way that the Data Protection Act said it should be. How would that flare up if you were going to I'm going to prosecute that person because they stole it and they've got my data? But then would it come back to say, well, you didn't protect it in the first place?
Right. So you're saying, could someone argue that it was your own neglect? But they're separate. So they're separate laws. You can't use one. I'm not a lawyer, but you can't use one breach of a law to say that another breach was justified. So if they've breached the Computer Misuse Act or whatever by hacking into you, they can't then. I don't think they'd get away with claiming, well, Data Protection Act says they should have protected it. Data Protection Act is more aimed at organisations to make sure that they're protecting the data of the people, customers that they hold. And I apologise if my Australian accent's putting you off, because I know the word data is coming up a lot. Data, if you prefer. Yeah, sorry about that. But data. Okay, it just sounds American to me. But anyway, backup software. So there's lots of software you can choose between, right? If you're in charge of this, like, managing backups and things, you need to decide what you're going to use. And there's lots of things you can think about. Some of them are a lot easier than others. Some provide automation and some don't provide any. Some provide some level of compression. Some, for example, will actually provide some encryption and access controls, and you might actually have different file formats and things that they support. Yeah.
Just back to what you said before, like say you're a company and you wanted to have offsite cloud backups,
Mhm.
would you not be allowed to do that?
No, you can, and I'll come back to that. So there are, if for example you use Google or Amazon for your backups, they allow you to choose if you need the data to be kept within the European Union. You can ask for that, and then they will make sure that your data is stored in servers in that geographic region.
You would be able to do it in like China.
I think that they have an Asia area. So if you use Google, you can say store my files in Asia, but they won't actually guarantee that it stays in Asia.
Okay.
But for like the Europe and the US, you can request that it stays in those areas. I think they even do Australia as well as an area that you can ask for.
I'm not sure what certificate it is, but the European Union see that certificate, so they can store it anywhere in the world. They're allowed to store it outside the EU,
Right.
but you've got to go through certification.
Right.
I think it's about.
They do or you do?
Pardon?
Who does? Who needs to go through?
If you want to store data outside the EU as a company, so you can store, Google can store it wherever they want.
Right.
I think it's about 5 ISOs they need, and about 3 or 4 other things.
Oh, okay, that's
And
interesting.
They can store it anywhere in the world.
Yeah, okay. But I think it depends what you need to be compliant with, because there are, like if you're in the US, for example, that's another set of compliance that you need to be able to, as an organization, say that you're compliant with their requirements. And for example, if you're in healthcare in the US, there's a whole set of compliance that you need to be aware of. If you are PCI compliant, so if you store credit card details, then you need to check with PCI compliance. And a lot of these cloud companies will specify that they are compliant with these various things. So then if you need to be compliant with certain laws and things, you can check with your hosting provider that they can guarantee that they are compliant. Yeah. Okay, so there are various standard tools you can use. So obviously copy, whoa, very exciting, CP on Linux. tar, which is tape archive, it just saves a whole bunch of files into one file, no compression or anything. You can use DD, which is data dump, and it copies exact data from one place to another, so you can use it, and probably you guys have used it in forensics modules and things, but you can use it, for example, to copy one hard drive to an exact copy on another hard drive. It doesn't do integrity checking, so if it might mistakenly be slightly different, but generally it tries to copy a hard drive to another hard drive. You can use CPIO, which copies to an archive. You can use dump and restore, similar, copies file systems. A very nice piece of software is rsync, and I use it all the time, and it's incredible. Maybe overselling it slightly, but that was actually developed by a guy called Andrew Tridgell, who I can tell you stories about. In the Linux community, he rustled some feathers that caused Git to be created in the first place, because he sidetrack a little bit, but Linux development, they had a version control system that was proprietary called BitKeeper. They were allowed to use it, but their condition was you're not allowed to try and reverse engineer it. And Linux guys, being Linux guys, Andrew Tridgell actually, I think he just started by typing help by connecting to it, and then that got them in trouble. And anyway, they were told that they can't use BitKeeper anymore. So Linus and Andrew didn't necessarily see eye to eye on that, but then that's what got Linus to actually invent Git. But anyway, that was sidetracked. But he created rsync. I think it was his PhD thesis or something. But what it does is it allows you to copy files across a network, and it only does like delta. It only sends the delta, so it does clever things to make sure that it's doing it very efficiently. And there's like loads of command line options. So that's a really good tool to use, and you can do things like differential and incremental backups and all that sort of stuff if you use the right commands. You can use RPC, which is very insecure. Don't ever use it. It just uses it allows you to copy from one computer to another over a network, but there's no encryption or anything. Horrible. SCP is the new secure version of that, and so that uses SSH to do that connection and send it over a secure thing across two computers. So that's actually really helpful as well. And rsync can actually use SSH as well. So yeah, so you know, redundancy. How are we going for time? Yeah, not too bad. So redundancy is about having, well, what does the word redundancy mean?
More than one.
Yeah, more than one. Yeah, essentially. So if we had a redundancy of rubbish bins in this room, we might have one rubbish bin there and one over here. Then if one got full, we've got another bin that we can use, just in case they don't manage to empty it in time. Or if someone stole a bin, we have another bin here. You know, yeah. Don't know why someone would steal a rubbish bin, but you never know. So RAID, right, and that's what you mentioned before. A RAID array is an example of data redundancy. So if one hard drive fails, you don't lose all your data because it does clever things, which we'll talk about in a second. So we've got hardware redundancy. So we might have power. So we might have multiple uninterruptible power supplies connected to a computer, or just by having one connected to a computer, that provides a redundancy in case the electricity turns off, the computer can still stay on for 15 minutes or half an hour, however long it gives you to like save all your work. And you might have multiple servers in case a server gets, you know, something wrong happens to a server and you've got another server that can continue to work. So redundancy is really good for error recovery and fault tolerance and all that sort of stuff. Disadvantages are that you might, if you've got accidental redundancy, that's bad. So for example, if your database is designed badly, you might have redundancy of information because you're storing the same thing twice, and that's just horrible, horrible thing to be doing, because then you need to make sure that it's synchronized. And say for example, you've got a database that includes what someone's surname is, and that's stored in two different fields. That's just asking for trouble for obvious reasons. If someone updates their surname and only gets updated in one place, then all sorts of bad things can happen. So it makes things more complicated having redundancy as well. And we need to keep monitoring the situation so that we know when we're in a degenerate state. So for example, if one of the rubbish bins is full, it's nice that we've got another bin in the meantime, but we actually want to know about it so that we can do something about it. Because otherwise the second rubbish bin might fill up as well, and then we've got rubbish overflowing or whatever. So fantastic analogy, isn't it? But yeah, the point is we need to know about it when we actually fall back to our redundancy. We want to know. It can be really hard to test redundant systems. Yeah, Chernobyl disaster. Probably you've all heard of it. It was a nuclear incident during a test of the backup cooling system. And testing the backup involved a number of complicated changes, and it didn't go very well. So they were testing the backup system, and while they were testing the system, it created one of the largest disasters that's ever happened. Basically, it was horrible, horrible incident. Yeah, the point is that's like quite an exaggerated example, but basically things can go wrong. So RAID. RAID stands for a redundant array of inexpensive disks, was the original definition, and then the people that wanted to make lots of money off it decided that they shouldn't include the word inexpensive in the description. Actually, we want you to spend loads of money, so they changed it now. So now it's a redundant array of independent disks. So yeah, go team. So group of disks, which is in the array, appears as one disk. So if we've got an array set up, the programs on the computer just see it as one disk, even though physically you've got multiple disks in there. And what it does is, if one of your hard drives dies, then you can continue to for it to work, and you shouldn't lose any of your data if one hard drive dies. If two dies, then that's another story. So you need to keep monitoring it. And there's a few ways you can do RAID. So there's hardware-based RAID, and that's where you've got a RAID controller. So it might actually be you can get a PCI slot or whatever for your PC, and that provides hardware RAID, and then that'll have SATA connections on it, for example, or whatever. You connect that into your hard drives, and then your operating system might not even know there's RAID there. It just sees the disk, right? It's got a driver so that it knows how to talk to the controller, but the controller does all the work in making sure that it all works fine. I guess the positive is that it's quite fast. It's really fast actually. It's got quite good performance. The operating system doesn't need to do any extra work. It's the RAID array controller doing the work. But it's a single point of failure, right? So if your controller dies, then that's like worse than a hard drive dying, because now you can't access anything. And then you need to be able to buy another copy that has the exact same controller, because if you can't, then you've lost all your data. So make sure you're buying a popular product or popular chipset. Probably you're right. I mean, if you're using hardware RAID, probably you've chosen one that's like quite popular, or at least.
I had problems with this when I first bought my own, like because it kept crashing one of the discs.
Yeah.
And I just had to keep resetting it, but luckily at the moment it's working.
Sometimes these hardware RAID can seem a lot more mysterious, because like you don't actually know what it's doing. It might have some lights if you're lucky.
Lights on the front, and then occasionally a cross appears. It's all over.
Yeah. So hardware's like, it's pretty good. Software RAID is personally what I use on most of my computers, and that's basically exactly the same thing, except that it's the computer doing the work. So it's the software on the operating system that provides the RAID array for the programs. So it does mean that the PC needs to do a bit of extra work, or the server needs to do a bit of extra work, because it's maintaining what's stored on each hard drive and everything. And you can add partitions and things to RAID arrays. It doesn't have to be an entire disk. So if you've got 5 hard drives, you can actually create the same size partition on each, and then just bam, make that into a RAID array, and then you can put something onto that, and then it's like stored across all of them. You can't usually dual boot, so you can't share a RAID array between Linux and Windows, because each of them do it in a different way, because it's the operating system doing it, and they're not compatible. So if I did boot into Windows, for example, I wouldn't be able to access my RAID array, which had everything in it. So you can't also boot directly from RAID usually. So normally what you'd have is a separate partition, or like nowadays you probably have an SSD which has the operating system, and then you have a RAID array which has everything else. Or you could just have the actual boot partition, like /boot, which is literally just grub on a Linux system, and it just starts the computer up, and then everything else can be on RAID. Firmware-based RAID is like the worst of both worlds, because it's software with some support from hardware. So it's okay. So basically, it means that like BIOS, for example, is aware of the fact you've got a RAID array, but the operating system's still doing some extra work. So you've got some hardware dependence, but at least you've got the flexibility of software RAID. And you can see when the computer starts up whether it's all going well, instead of having to do it once your operating system's running. Monitoring these things can be a bit tricky, and one of the problems that you can have with software RAID is you don't get those lights. You kind of have to look at software, and then to figure out which hard drive has died is not straightforward. Sometimes it's like, oh, one of the 6 hard drives has died. It's like, yeah. If you're really smart, you will have labeled your hard drives, but yeah. So data striping, or is it stripping? Striping? How would you? Striping, I'll go with, is basically where it takes the data and it stores it across the hard drives. So say, for example, you had a like this much data, and you had 5 hard drives to share it across. It would actually break that up into little blocks, put the first bit onto this hard drive, first bit onto the next one, and next one. And what that does is it can make things incredibly fast, because hard drives take a certain amount of time to get data out of. And if you can read from all of the hard drives at once to grab the information, it can go super fast. So you can just go, yeah, give me the information, and it actually can speed things up. So it's faster than reading from the same amount of data from a single disk, because you can get more of it from all the disks all at once. You get parity, which is basically error detection. So and it can also provide error correction. So that's where you can detect whether something goes wrong. So if something gets corrupted, it's got like a checksum kind of thing where it looks at it and goes, okay, something's wrong, something's changed. but then also you can recover the original data. So one hard drive dies, it gives you the ability to recover that information back. And mirroring is like RAID 0, where you basically have this, I think that's what you said,
I've got RAID 1.
all right. Where you basically have the exact same copy on multiple disks. So yeah, so it will store that. Sorry, you're right, RAID 1. So the RAID levels is just a way of saying which of those features you have. So you can say RAID 0 has striping, no redundancy. RAID 1 is mirroring. RAID 3, dedicated parity disk. RAID 5 is like 3, but parity is stored along with data across all the disks, which RAID 5 is really good. So basically, it's probably the most popular configuration, and means that if one of your hard drives dies, you still get all of your data. You don't lose any data. So if you've got 5 hard drives, the way it works is you've got 4 hard drives worth of space, because the rest of it is used for parity across the disks. So yeah, it's quite good. RAID 6 is basically the same, but with 2 parity. So then you could lose 2 hard drives and you'd still recover everything. But then you've got, basically if you had 5 hard drives with RAID 6, you'd have the storage space of 3. But you can lose 2 hard drives and you don't lose anything. And that information is just there. You can also have hot spares, which is where you basically have a disk standing by that it can automatically use if a hard drive dies. So if a hard drive dies, it'll just build onto the spare disk, which is really nice. But otherwise, you need to replace the disk that's broken and rebuild the contents, which usually happens automatically. You just plug a hard drive in and it will just do it. So there's a diagram. I don't think I need to go over that. Basically, this just has the spare hard drive where, if it needs to, it'll build onto that. So Linux has really good support for RAID. I think on Windows, only certain versions of Windows have RAID support for software RAID. So if you, you can do any of those things, and the kernel influence RAID with the MD device driver, and you see like dev/md0, and that's the device that you've created with RAID. And if you happen, depending on the version of Linux you're using, you might have to use command line tools and stuff. But one of the reasons I really like OpenSUSE or SUSE is with YAST, it can actually do it all like really easily. You can just, it's got a really nice interface to creating RAID arrays and things. You can actually say, all right, use these partitions, create a RAID array, and then use these ones to create another RAID array, and I want this file system on it, and mount it to this directory. It's all really easy, and it actually shows you a graph at the end. You can see your graph of where all the partitions and everything and how they're turned into. It's really nice. I installed Ubuntu onto one of my computers at home, and then there was nothing similar. I got it all working, but it was all by a command line to get like all the RAID array and stuff working. So, but yeah. Anyway, either way, you can get it working. So, graphical interfaces. You do need to monitor logs for disk failures. And you can use log shipping, which is like a warm standby where you make copies to a backup server of databases. Load balancing. I hope I get time to mention the cloud stuff. So load balancing is where you distribute workload across multiple devices or computers. So for example, on DNS you might have a number of different IP addresses that point to Google. So when you go to Google, you get one of those IP addresses and use it, but they could each be pointing to separate load balancers or computers, servers. Same thing can happen with other technologies. A failover is when like something stops working. So if you've got a load balancer, which is like a device which sends you through to one of the servers, for example, and one of the servers dies, then it can fail over to a separate server and stop sending a request to the one that's not working properly. Redundancy is not backup, Dan. So Journal Space was a blog site. You probably don't remember them, have never heard of them by now, because in 2009 a disgruntled ex-employee allegedly deleted all the hosted blog posts. There were no backups except for the site's source code. Only RAID. So they used RAID. But with all the blog posts lost, the organization sold the domain name and never to be heard of again. So and there's a little story there that basically the RAID doesn't protect you against that, right? It only protects like a hard drive dying. It doesn't protect accidental deletion or anything like that. So backups can also go wrong. So couch surfing had like quite a big hard drive problem where they lost everything and they actually had to work to rebuild it all from scratch, basically. And Gmail lost all their emails for 0.02% of their users, which for Gmail you can imagine that's a lot of people. But luckily Google have tape backups, so they actually have tapes that they got out and managed to get them back. So yeah, the cloud. All right, how long do we have? 5 minutes. Okay, so cloud computing basically is where you've got a network of servers, usually remote, providing services for you, right? So there's a number of different kinds of cloud infrastructure. So you've got infrastructure as a service. So that's where you basically have a way where they host VMs for you, basically. So if you sign up to, like, if you use OpenStack or Overt or something like that, you can actually have your own virtual machines and stuff that you run on someone else's servers, and it, you don't have to manage the hardware or anything like that. That's all managed for you. You just have some VMs that you want it to run, and that's how a lot of organizations run their services and things. So they'll have VMs running on like Amazon's cloud or whatever. So you create that stuff, and you can have servers or desktops. So you can have virtual desktop infrastructure where you might actually have a VM that's the machine that you want your employees to use, and they just get the desktop of that, and that's all hosted on infrastructure as a service. You can have platform as a service, which is basically where they host some software for you. So for example, Google App Engine, you can write a Java application that uses Google App Engine. You can deploy that application into their cloud, and then you don't have to manage operating system or anything like that. You just manage your piece of software, and they provide the foundation to run that. And software as a service is where you're just using software that's hosted somewhere else. So for example, using Google Drive or Google Docs or Gmail, or basically most of Google's products are cloud-based products, in that it's just software you use and it's all running on someone else's computer. So the way that cloud computing is so great, or the advantages that it has, is because of virtualization. So it can do all sorts of clever things because it's not dependent on the hardware it's running on, it's just running on top of that. And it has usually resource pooling. So for example, there might be massive amounts of servers and things, and depending on what, when you run your VM on their servers, it'll use the resources that are available to do that. And it provisions on demand, so it provides elasticity. So you can say, actually now I need 5 million VMs, and it'll fire all those up using all the Amazon servers and things. And you pay for what you use, basically. So you pay for the amount you use, and when you don't need them, I don't need any VMs, or I just need one at the moment, and then you're not paying as much. So it allows you to scale up and down really quickly and easily. So you've got a lot of agility there. So public cloud is where you basically outsource it and you run it on someone else's servers and they manage it all. Private cloud is where you basically do all of that, use all those same technologies, but do it within your own organization. So you set up all the cloud infrastructure and servers and stuff, just so that you can run the virtual machines and stuff on top of it. And hybrid is something in between. So if you wanted to make sure all the most important business information was kept on site, then you might have a private cloud and you might use a public cloud for the stuff that doesn't matter in terms of, like, privacy and things like that. So you can use that to provide your redundancy, so that you can basically, you don't have to worry about as much as one particular piece of hardware dying, because it's all independent of that. And you can use it for failover as well. So there are failover services. You can use caching services like Cloudflare, where they will actually, if your server goes down, they provide their own cached version of the information. And you can also use software as a service data storage services to do your backups on, right? So you can use Google Drive to put your information on. That scales quite nicely. Again, you pay for what you use. There might be a free certain amount, but then if you go over that, you're paying for how much you're using. So you can use that for your remote backups. How reliable that is depends on how much trust to the service and whether they're likely to go away anytime soon. But yeah, so there's consumer grade, which is like Dropbox. And then there's like online data storage, so like Google Cloud Storage, Amazon S3, Amazon Glacier, which are designed more for business needs and long-term backup and things like that. And you can use SpiderOak, which is an example of an encrypted one where it's like Google Drive, but it encrypts it on your own computer before it goes onto theirs, which is very nice. So security can be really complicated in the cloud because you're talking about shared hosting, multiple people's software running on the same servers. You might have lots of servers. You've got all sorts of different things to manage, and one security breach can have huge impact. And the attacks could come from other people that are using those services. So the main advantage is cost, and the fact that it's managed by someone, but then it makes it impossible to audit. So you can't look at the physical security, you can't check it, and basically all of your data is being stored on someone else's computer, and the people who are managing that probably have access to all of that data. So there are definitely privacy and legal compliance issues that we have talked about, and there's a lot that's out of your control. So in conclusion, it's important to make sure your organization can function under adverse conditions, and you need to be able to recover from problems, and the way we do that is with data redundancy and backups, and cloud computing does provide a possible solution. But as we talked about, there's a lot of advantages and disadvantages that you really need to carefully consider.